Okay, this is AP set up to 4.3. This first video we're going to do numbers 1 through 6. Some of the easier ones I'm going to go through a little bit quicker than the other ones. So the first one, considered to be a pretty easy problem. They want to find out where the function shown is continuous but not differentiable. So continuous and not differentiable. If we look at each point, at point A, it is continuous and it's not differentiable because there's a sharp turn, so our answer is A. I'll go through the other ones and tell you why they do not work. B does not work because there's a hole in the graph, so it's not continuous. C does not work because it is continuous and it also is differentiable. D does not work, obviously, because there's a break in the graph, so it's not continuous. And E does not work because it is continuous and it's also not differentiable. So our answer is A. Okay, next question. Number 2, they want us to find the equation of the tangent line to this function at its point of inflection. So the first step would be to find the point of inflection, and to do that we need to define the second derivative. So the first derivative is 3x squared plus 6x. Second derivative is 6x plus 6. To find the point of inflection, set it equal to 0, and we're also going to factor at the same time. Because there is a point of inflection, we know that it has to occur at x equals -1. If I'm going to write the equation of the tangent line, I also need the y coordinate of the point of inflection. So we're going to take x equals -1 and we're going to plug it back into our original function. So that's going to give me y equals a -1. That's going to give me +3 and +2. So the y coordinate of our point of inflection is at 4. So at -1, 4 is our point of inflection. And now to write the equation of the tangent line, I need the slope, and slope is found by finding our first derivative, and we're going to plug in the x coordinate. So we're going to do 3 times -1 plus 6 times -1, and that gives me 3 minus 6, which is -3, and that's our slope. And now to write the equation, it's going to be y minus 4 equals -3 times the quantity of x plus 1. Y minus 4 equals -3x minus 3. Y equals -3x plus 1. And our answer would be A for that one. Okay, next question. Question number 3. The graph is represents a leaf falling from a tree into a swirling wind. The graph shows the vertical distance. So this is a position function, and it shows the vertical distance the leaf has traveled against time. And they want to know over what interval is the speed of the leaf the greatest. So the first thing we need to discuss is that speed is equal to the absolute value of velocity. Now, if this is a position function, the velocity would be the slopes of each one of these line segments. Okay, so we need to check each interval. So the first interval we're going to check is from 1 to 3, and we're going to find its slope, and we're going to make it positive. All right, so that indicates right here. Now, please be sure you notice that the y-axis goes up by 5. So this is going up 5 and over 2. So the slope there is 5/2. Okay, next, I'll try the next interval, which is 3 to 5, which is indicated by this line segment. Now we're going down 5, 10, and we're going over 2, so it's 10 over 2, so the slope there is 5. Now, even though it's negative, we're doing the absolute value of it, so don't forget that relationship between speed and velocity. Okay, next interval is between 5 and 7. Okay, so the one thing we definitely know is that the change in the x is 2. Now the change in the y we're not sure, but it's something less than 5. You can say, the change is 2.5, but either way, it's still going to be less than the interval from 3 to 5. Okay, and then last but not least, we need to check the interval from 7 to 9. Okay, and again, we know that the horizontal distance, the change in the y, is 2. The vertical change is 5 and a little bit more, but it's definitely less than 10. So even if you said that was 7.5, that is still going to be a value that's less than the interval from 3 to 5. So this is our answer for when the speed of the leaf is the greatest, which is B. Okay, next. Now there's two ways to do this next problem. We're going to find the limit as x approaches 1 as the square root of x minus 1 over x minus 1. So the first way is algebraically, and we do need to note that direct substitution doesn't work. We should always try direct substitution first, but that does not work. So we're going to multiply top and bottom by the square root of x plus 1 over the square root of x plus 1. So the limit as x approaches 1, we're going to do a little distributing here, so it's going to be x minus 1 in the numerator, the middle terms cancel out, and the denominator is just going to be an x minus 1 times the quantity of the square root of x plus 1. Simplify, the x minus 1s can cancel out, so now we're going to do the limit as x approaches 1 of the square root of x plus 1. And now we can use direct substitution and just plug 1 in for x, and when we do that we get 1/2. And our answer should be B. Now, you can also do it using L'Hopital's rule. And L'Hopital's rule is, let me write the problem down again first, the square root of x minus 1 over x minus 1. Again, first you need to show that direct substitution does give you the indeterminate form, which is 0 over 0. And that has to be true to use L'Hopital's rule. And now we just take the derivative of the numerator and the derivative of the denominator. So let me just rewrite this a little bit. That's x to the 1/2 minus 1 over x minus 1. So now if I do the derivative of the numerator, that's 1/2 x minus 1. That's going to be a 0, and the denominator gives me 1. Simplify that a little bit to 1 over 2 times the square root of x. Now we can use direct substitution, plug it in, and we still get 1/2. So either way works. Okay, so that is number 4. Next is number 5, and let's see what they want us to do for number 5. Just find the derivative of this. Okay, so the derivative of this, we got to use the chain rule here. So it's going to be 2 cosine x. The derivative of cosine is negative sign, so put the negative out in front. And then minus another chain rule, a 2 sine x cosine x. So that gives me, those are like terms, a negative 4 sine x cosine x, which is E. And number 6, they give us acceleration with this as this function, and at time 1 the velocity is 4, and also at time 1 again the position is 6. They want to know at time 2 what's the position. So we need to figure out the position function. So we're going to have to integrate the acceleration twice. Okay, so we're going to take the integral of 3t plus 2 dt. The integral of that would be a 3t squared over 2 plus 2t plus c. Now again, I need to know the actual velocity function, so I need to figure out what c is equal to. Okay, and this is where we're going to use the ordered pair. At time 1, velocity was 4. Okay, so this is going to be 4 equals. We're going to plug a 1 in for t, so that's going to give me 3/2 plus 2 plus c. 4 is equal to, that's 3.5 plus c, so c is equal to 1/2. Okay, so now I'm going to integrate the velocity function, which is 3t squared over 2 plus 2t plus 1/2 dt. Okay, so now to integrate this, we'll add 1 to that, so it'll be t cubed and the 3 in the denominator. So now what this is going to become is just t cubed over 2, because the 3's will cancel out. This is plus just the t squared, because it'll be t squared over 2 and the 2's will cancel out, plus 1/2 t plus c. Again, now we have to use the ordered pair. At time 1, position was 6, so we can figure out what c is. So this is our position function. So now we're going to do 6 equals 1 half plus 1 plus 1 half plus c. So that 6 is equal to 2 plus c, c is equal to 4. And now our position function is going to be t cubed over 2 plus t squared. Whoops, it's kind of messy. Let me erase that. Plus t squared plus 1 half t plus 4. And now I want to know what it is at 2 seconds. So we're going to plug in 2 for t. So I'm doing s sub 2. So that's going to be 8 halves. That's going to be a 4. That's going to be a 1. And that's going to be a 4. So we have 4 plus 4 plus 1 plus 4. And that is 13. And that would be choice D. Okay, so there are the first 6. You can look at the next video for numbers 7 through 13.